Hello, this is Period 1, Groups 2 presentation on the Combined Gas Law. The members are Ali Chaudhry, Kelly Lin, Vanessa Chien, and Sarah Yoon. The Combined Gas Law is a mathematical equation that relates temperature, pressure, the number of particles, and volume into a mathematical relationship. The equation is P1 times V1 over T1 times N1 equals P2 times V2 divided by T2 times N2. P equals pressure, V represents volume, T equals temperature in Kelvin, and N equals the number of particles. Since the number of particles usually remains constant in most problems, it is often left out of the equation altogether. The combined gas law is derived from Boyle's law, which shows the inverse relationship between pressure and volume, Charles' law, which shows a linear relationship between temperature and volume, Gay-Lussac's law, which shows the linear relationship between temperature and pressure, as well as the linear relationship between the number of particles, or moles, and volume. Using the combined gas law is often more practical than using the individual laws by themselves, such as Boyle's law, Charles' law, and Gay-Lussac's law, since usually more than one factor is changed at a time. For example, if a helium-filled balloon is released into the atmosphere, the volume changes as a result of the changing pressure and temperature that the balloon is exposed to. When solving an equation using the combined gas law for a specific variable, first rearrange the equation and then plug in all the values and solve. For example, when solving for volume, rearrange the equation so it looks something like this. V2 equals P1 times V1 times T2 over T1 times P2. Notice that when you plug in values for T, or temperature, make sure to first convert them from Celsius to Kelvin before solving for the unknown, or else you will come up with the incorrect answer. Remember that K, or Kelvin, equals degrees Celsius plus 273. Some real-world applications for the combined gas law includes using weather balloons, scuba diving, using combustion engines, as well as any other applications for Boyle's law, Charles' law, and Gay-Lussac's law, such as boiling water, pressure cooking, and using gas cylinders. Scientists use the combined gas law for weather balloons because it is necessary to determine the volume of air that should be put into the balloon, since when the balloon is released up into the atmosphere, the pressure decreases and the temperature may fluctuate, either decreasing or increasing, forcing the volume of the balloon to usually expand. For scuba diving, as scuba divers go deeper into the ocean, the pressure increases and the temperature decreases, changing the volume of air that is inhaled into the lungs. For combustion engines, when the accelerator is pushed down, this activates a throttle valve that sprays droplets of gasoline mixed with air into the engine. The mixture goes into the cylinder, where the piston moves up, compressing the gas and air. While the mixture is still at a high pressure, the electric spark plug produces a flash that ignites the gasoline-air mixture. The heat from this controlled explosion increases the volume of air, which forces the piston down into the cylinder. This opens an outlet valve, causing the piston to rise and release exhaust gases. As the piston moves back down again, an inlet valve opens, bringing another burst of gasoline-air mixture into the chamber. The piston, whose downward stroke closed the inlet valve, now shoots back up, compressing the gas and air to repeat the cycle once again. The combustion reaction that causes the crankshaft to turn and causes the wheel to rotate is a result from changes in pressure, temperature, and volume. Here are some assignments or problems that would be good practice to use when you are trying to figure out how to use the combined gas law. Remember that when you are plugging in values for temperature, be sure to convert them to Kelvin first. Also, before you solve for the specific variable that you are solving for, make sure to rearrange the equation. And here are some sources that were used to create this PowerPoint.